Today we will be talking about optimization problem for investment. The problem statement in front of us is that we want to maximize a portfolio. We want to get the best portfolio with a beta of 1.3. We have a total of 8 funds, uh, and we have the average yearly returns. We can invest only up to 30% in a single fund for diversification, and out of the 8 funds we have to have money in at least 4 funds. What is beta? Quickly I can mention, beta is the coefficient of price uh, compared to the stock market. So for example, if the beta is 1.51 it or 1.3, if I can just take this example of, we if the any 10% rise in the stock market is going to make that particular stock go by 13%, and if the stock goes down by 10%, it means that the stock will also go back by minus 13%. So what we are trying to do here, we are trying to make an optimization of the share. So we have right now we have distributed one among 8 shares, so we have 12.5%. So basically we want to optimize the share price, the share allocation, according to the maximization of expected returns that is there. So we want to maximize this particular column, the maximize this by adjusting the share. So this is what we are trying to do here. This is the decoding the uh, mathematical, the problem statement to the exact data related statement is, we have an allocation right now, equal allocation of 12.5, but we want to allocate optimally according to the uh, so that we maximize the expected value, and we have some constraints that we showed earlier here. So these are some basic constraints that we have regarding 4 funds and at least 30% maximum allocation in one fund. So this is the now to go ahead, and how will we do this is, we will take the help of goal seek function. So the goal seek is here. We have a excel solver in which we can do this particular analysis. Now if you don't have this, then there are different steps to do that. You need to go to file, options, add-ins, and then you need to go here and get the add-ins from the solver. So this is the first step. Now coming back to the particular sheet, now how we will maximize this uh, expected value by allocating the share. So we'll go to solver. So what is our objective? As I told you, we want to maximize the expected value by changing which variable cell, by changing the share. And now constraints. So the first constraint is, this should be equal to 1, because we cannot have it more than 1. Add. Second will be the fund count should be greater, the fund count should be equal to or less than, equal to the minimum fund. So basically minimum fund for sure, the fund count should be greater than or equal to the minimum fund, because it can be it cannot be 3, but it can be 5. That is the scenario. So what we will do is, we will do cell reference of, first we will take the cell reference of C15, then we have to do it less than D14, C15 less than, and correct. Then next will be, this should not be negative. This should not be negative because we don't want any share to be less than 0. Add. Then next what we want to do is we want to make sure that the target beta is less than the partial beta. We don't want the to take high risk. So what we will do here is we will take this should be greater than or equal to this. Okay, F11 should be greater or equal to C12. Add. Now we have I think we have done everything, so we'll just do okay. Cell reference and we okay. Let me cancel. Now we have 4, so we have to do one more constraint. Let us see the C15 is greater than E11 is equal to 1. Yes, the target should be less than 30. So one more is there. This particular dish should be less than or equal to 30. This should be less than or equal to 30 because we know that it should not be greater than the maximum share, right? So less than or equal to the maximum share. So this is the fourth one. So now we have all the constraints, all the 5 constraints that are there. 1, 2, 3, 4, and 5. So now we have to make it non-linear because it's a non-linear problem. I have talked more in details about all the other options in my detailed course, and you can get the link below. I am just giving you a quick reference of how we can do this particular step. There are a lot of things in solver parameter that you need to know, but this is just a basic understanding of how you can do it. So let me just click solve. And now I will try to get all the reports and I can explain all the reports in details, but now we will take the solver solution. So now we get the answer with uh, we have allocation in 4 funds that they have selected. I will just make it green, and we now with this particular set we have a expected value of maximum of 5.2% overall expected return of 5.2%, which is good compared to all the situations that we have given. So and we can see that all the constraints have been validated, so nothing is more than 30%, everything is positive. We have not our beta is less than 1.3, so it is not even risky. It is very less risk, right? 1.062 means every 10% of increase in stock market our fund will increase by 6%, and similarly every 10% reduction our stock will also increase by around 6 reduce also by 6.2. So it's not that volatile, and it is safe investment and a very good return. So this is one of the easy way to use the power of solver without doing any code to solve such problems. And more details in my course about how to do things at different use cases, and how we can learn more about this but powerful tool that is there. You had seen, right, in the matter of 10 minutes I solved a problem very efficiently, and this can be used for many use cases. So talk to you more in the next video. Thank you. Please do subscribe and like and share, and help me spread the awareness of data science. Have a great day. Bye bye.